Hello everyone, my name is Dr. Louis Nisiotis. I'm from the University of Central Lancashire, Cyprus, and today I will be presenting the paper I'm co-authoring with my colleague Dr. Luba Alpel from Sheffield Hallam University, entitled Evaluating Presence and Technology Acceptance of an Intelligent Reality Virtual Museum Prototype. The concept of intelligent reality has drawn significant research interest over the past few years. It refers to the fusion of integrated technological innovations to develop complex computing systems aiming to blend the physical world with digital spaces and enables humans and machines to seamlessly work together and leverage each other's strengths. This paper explores the potentials of using artificial intelligence, robotics, and immersive technologies as a fusion to develop intelligent reality systems to disrupt the way humans explore and understand data, interact with real and digital worlds, and with each other. This paper demonstrates an example of a cyber-physical social ecosystem prototype and presents the results of an evaluation study which focuses on technology acceptance and user experience, mostly focusing on the subjective feeling of presence and overall system perceptions of users experiencing a virtual museum. There has been a significant leap in digital transformation of the society, and there is large-scale introduction and implementation of digital spaces, extended reality, this umbrella term to encapsulate virtual, augmented, and mixed reality environments, Internet of Things, and other technologies into our lives. And there is an introduction of the metaverse, this trend keyword that is used to encapsulate persistent virtual universe, merging synthetic environments with reality. And major tech companies and technology innovators have actually leveraged the momentum and announced their implementation in the metaverse. So metaverse actually became so popular that the industry has actually embedded new types of business models into their corporate strategies to actually involve the metaverse. Even policies of national and international organizations have actually been modified to accommodate this new ecosystem. And technology developers are actually devoting significant efforts in developing tools and environments that feed into the metaverse. So, taking into consideration these significant technological advancements, there are many potentials of deploying immersive, intelligent digital worlds that are controlled and influenced by AI and humans interchangeably. We've got opportunities of designing and developing adaptive virtual worlds capable of understanding how users behave and support and improve and enhance their interactions with the environment. We can implement intelligent agents capable of perceiving, thinking, acting, sensing, providing interactions with users and the environment. We can implement social components like social agents through voice recognition, speech synthesis, language understanding, and essentially supporting this agent to human interaction. There is the implementation of digital twins, bringing together humans and AI, helping to visualize through immersive XR and used for complex visualization. There's the concept of Internet of Things and Internet of Everything, of interconnected smart objects and services that establish human to human, human to physical, and physical to physical connections. Essentially, all these solutions, all these technological innovations, are what are driving the new era of intelligent reality. And some of the key architectural concepts that foster intelligent interactivity between real and digital worlds are the so-called cyber-physical systems that employ computational and physical capabilities, such as sensing, actuating, communicating, to integrate physical information systems. There is also the concept of cyber-physical social systems, which are essentially introducing a social element concerning human input and how this human input is influencing the system, the cyber-physical system. There is a further architectural extension recently been introduced, and this is in the form of cyber-physical social eco-society of systems that are essentially inheriting computational, physical, and social capabilities of cyber-physical and cyber-physical social systems, and amalgamate realities via real and digital agents through their digital twins and through actuators that interact with humans and their avatars synchronously, essentially providing direct links to both reality in an ecosystem of multi-directional data stream. So, to investigate the opportunities of such a cyber-physical social ecosystem, we have designed a case study developing and evaluating a virtual museum and conducting our empirical evaluation. So we have created a digital environment, a virtual museum, and we have installed the system and we have evaluated the Cyprus Computer History Museum. The Cyprus Computer History Museum is actually a technological museum that is located in Nicosia, Cyprus, and is dedicated to the education on the history of computers. So we have created a virtual reality museum that is essentially a 3D multi-user virtual environment where users can connect and coexist with each other and communicate with each other. And we're featuring several computer exhibits. We provide functionalities such as AI guide agents to navigate and help users guide around the environment. We provide some social interaction through voice over IP and textual chat. This virtual environment is actually running on smartphone devices using low-code cardboard-based head-mounted displays. So now, to establish this the physical link, we have established the turtlebot robot, as you can see in the images, which is a real robot that is actually placed in the museum premises, and you can see its digital twin actually existing and shadowing its movement in the digital environment. So, to conduct this investigation, we wanted to investigate users' perceptions towards technology acceptance, presence, and environment evaluation. We wanted to investigate the user perceptions based on how enjoyable they find it, how easy of use it is, how useful it is, perceptions towards personal innovativeness, and intention to use. We wanted to investigate potential relationships between these constructs that form the technology acceptance model, and we wanted to identify the user's perception of presence in the virtual environment. Furthermore, we wanted to understand the user perception of the environment design and the way they can control the environment. And last but not least, we wanted to understand the relationship between the concept of presence and the user's perception of the environment through the constructs that make the technology acceptance. So in order to collect data, we have used the technology acceptance model, the presence questionnaire, and we have also developed our own environment evaluation questionnaire. To run the experiment, we had participants connecting to the system from remote locations. We have they had to install the virtual application museum on their smartphone, and we have provided them in advance with a cardboard-based head-mounted display. As soon as they connected to the system, they were landing in the virtual orientation area in order to learn the basic functionality of the system. And they were then requested to navigate the environment, read around the different educational materials, study the exhibit, and also interact with the digital twin of the robot and the actual AI agent in the environment. This session took about 40 minutes, and users were administered a post-experiment questionnaire that was essentially asking them to describe their experience in the virtual world. The overall experience was running for 2 hours in 2 different sessions, and essentially participants were connecting at time of their convenience in the virtual world. We have collected information from 16 participants, we had 10 males and 6 females between the age of 18 and 45, that they had limited experience with virtual reality. They seem to be mainly comfortable in setting up their cardboard, and before conducting any statistical analysis, we've investigated and tested the normality assumptions, and we also ran a Cronbach test to test the reliability of our scales, even though TAM and presence are reliable scales that have been used extensively in the literature. So the TAM results were investigated first, and essentially participants have perceived the environments as enjoyable, as easy to use, and also useful. The results show a relatively high degree of personal innovativeness, and participants have expressed positive intentions to use the environment if they had access to it, essentially demonstrating a high acceptance of the system as a tool to support their virtual museum experience. We further investigated the TAM results for intercorrelations using Pearson correlations coefficient. And the results have revealed significantly strong correlations between perceived usefulness and intentions to use, and also perceived enjoyment with perceived usefulness. These results essentially can suggest that as the participants perceive the environment to be useful, they had more intentions to use such technology for the future. Now, furthermore, participants have perceived the environment and the experience as useful and enjoyable. Essentially, this can actually indicate that the more meaningfulness of the experience, the more enjoyment can actually be achieved. We've also identified strong correlations between perceived enjoyment and intentions to use, as well as between among the perceived ease of use and perceived enjoyment, indicating that participating in enjoyable virtual reality experience can actually lead to behavioral intentions of using such technology in the future. And also, it can indicate that the easier the environment is to use, more enjoyment can actually be achieved. We've also identified moderately strong correlations between perceived ease of use and perceived usefulness, suggesting that the easier, and with the intentions to use, suggesting that the easier the environment usage is to the user, the more useful the experience and the higher intentions to use in the future. We identified some weak correlations between personal innovativeness and the rest of the TAM construct, and this can actually indicate that the individual traits and willingness of participants to test new technologies didn't really affect any of their perceptions regarding enjoyment, usefulness, ease of use, and intention to use of the system. We then investigated the presence results, and we had some participants indicated that essentially they had quite high, they've developed a high degree of presence in the environment with good control over the environment, positively evaluating the sensory factor and the realism factor, and indicated there were only a few distractions that could diminish their presence experience in the virtual world. We then further evaluated the environment, and users found it fairly easy to navigate and interact. They really enjoyed the ability of seeing the real world through the eyes of the robots. They've positively commented on the video quality and the live stream of the physical museum. However, they did indicate that there were some delays between the live stream feed. And also there were some issues with interactions with the robot in the virtual world, as well as communicating through the textual chat and communicating with each other through the smartphone VR technology. We then further tested correlations between presence and the environment evaluation results with the TAM constructs. And then the results have actually revealed significantly strong correlation between presence and perceived enjoyment. And this suggests that developing this immersive feeling of presence can actually contribute towards the enjoyment of the experience. There were moderately strong relationships between presence and perceived ease of use and with intention to use. These findings can actually suggest that the easier the environment is to use, higher degree of presence can actually be achieved during the experience, and consequently, the more achieved presence, the higher intention to use the environment in the future. The personal innovativeness was actually strongly positively correlated with environment evaluation, and this could indicate that the willingness to try out the technology may actually relate to more positive perceptions of the overall environment design. Furthermore, we've identified moderately positive correlation between perceived ease of use and the environment evaluation, which essentially it can suggest that the easier the environment is to use, the higher the perceptions towards its general evaluations. So overall, users have actually accepted the environment as a technological mean to support their visit into the virtual museum. So to address our first research question, the environment was actually found very easy to use and useful. There were high degree of behavioral intentions on using this technology and this application for the future. To address research question 2, we've identified that the constructs that form technology acceptance are actually correlating, and the results indicate that users have participated in enjoyable, useful, and easy to use VR experience, which could lead to higher intentions of using such a system in the future. And we've identified that an easy to use environment can make the experience more enjoyable. Addressing research question 3, we have identified high degree of presence in the virtual world. Users have actually achieved a very high sense of presence, and they positively evaluated the design and the environment. Furthermore, users positively evaluated the environment's design and the ability to see the real world through the eyes of the robot. They found it easy to navigate and to interact, but also have identified some difficulties when interacting with the robot and communicating with each other, helping us to address our fourth research question. And our last research question, the importance of the feeling of presence in the VR experience and how actually it contributes to the enjoyment of the experience, with the possibility of essentially leading to higher intentions of using the environment in the future. We've identified that the easier the environment is to use, this contributes to a more positive perceptions towards the design and the functionality of the virtual world. And we've identified that users with more willingness to actually try the technology may end up perceiving the environment more positively. So, future work and some of the implications. We're considering to redesign the environment by taking into consideration the user's feedback and essentially implement additional functionalities and conduct further system and user evaluations. What we've learned from this experience is that the layout of the VR environment must be easy to navigate and must be easy to interact with in order to support feeling of presence, in order to support technology acceptance. We've identified that the interactions with objects and elements in the environment should be simple, should be responsive, and also users should be able to easily anticipate them. We've also identified that it's important to have short and meaningful activities to help users orientate easier, interact with the system easier, and be able to meaningfully experience the virtual world. And also, it's important to accommodate for limited processing capabilities of the devices. It's key to ensure a smooth visual experience for the users when exploring and interacting with the virtual worlds. And also in cyber-physical social ecosystems, synchronicity and the speed of service are very, very important. Therefore, it's important to ensure that we're developing systems like that, enough bandwidth available to process this multi-directional data stream and to support the multi-user infrastructure and social element of the system. So the development of complex computing systems that leverage the power and potentials of emerging disruptive technologies are starting to rise. In this paper, we presented the proof of concepts cyber-physical social eco-society system that aims to seamlessly blend real and digital worlds using VR, robots, and AI. The system described and evaluated is an example of a new generation of systems with integrated computational, physical, and visualization capabilities, demonstrating how it can be applied into the context of virtual museum, but is also applicable to a plethora of other domains. Thank you very, very much for listening.